Hello all, this is Andre Duval, and this is my project for Physics 231. For my project, I actually chose to do a concept from Physics 130, and that is momentum. Not just momentum in general, it is inelastic collisions. So I actually used a Matlab app that I actually built. I modified it a little bit for this presentation, not much, but it will get the job done to explain momentum for us. It uses a classic problem that we use often, that we solve often in Physics 130, and that is the shooting of the block problem, which is an inelastic collision. It's when a bullet is fired from a gun, it hits a block, it embeds itself in the bullet. The bullet embeds itself in the block, and then the block and the bullet travel through the air. Now, momentum is conserved because it's a collision. It happens in both inelastic and elastic collisions. And because it is inelastic, kinetic energy is not conserved. So if I run the program, hit run, it opens my app that was written. So here we have the gun, here we have the block, and here I can adjust different mass of the bullet, the velocity, and the initial velocity, and then also the block's mass as well. And this will give us the after contact velocity, V final, and how far it traveled. So I'm not going to fire it yet, but I'm going to go to Word and show the equation for momentum. So here we have M1V1, not momentum, but inelastic collision. We have M1V1 plus M2V2 equals M1VF plus M2VF. This right here is the mass and velocity of the bullet, and then we add it to the mass and velocity of the block. Now this is just going to go to 0 because it's at rest, the block, and this should equal the V final times M1, if we go down here, times N1 plus M2. We can factor out VF since they are the same thing. Then coming down to here, we can solve this equation for V final, which will give us M1V1, and then we divide right here. This comes down here. M1V1 divided by M1 plus M2. All right, and that should give us the final velocity of the block with the bullet embedded inside of it. Now, I'm just going to use a couple example values. So we have the block right here. This is going to be 100 grams. When I plug it into Matlab, I'm going to have to plug it in as a kilograms. That's just how I wrote my program. And then we have, this is the bullet's velocity. And we're gonna have it moving at 50 meters per second, which it's pretty fast. I think that's pretty good. I think if memory suffices, I'm not 100% positive. I think like a 40 caliber is like 47. But so anyway, block's at rest, so it's 0. No, nothing to do there. So, and then we need mass of the bullet mass equals, we're gonna do 5 grams. So it's a 5 gram bullet, and this all gets plugged in down here. So we have mass of the bullet times the velocity of the bullet. So 5 times 50 divided by the mass of the bullet plus the mass of the block. This is in grams. Gives us 75 over 15. This should come out to 238. Now going back to Matlab, I'm right over here. I'm gonna go to the app, and we agreed that the bullet mass would be 5 grams. Initial velocity will be 50. All right, so 5 times 50 divided by 5 plus, and then we need to have the mass of the block, and we said it was going to be 100 grams, which is 0.1 kilograms. And now if we hit fire, bullet fires, hits the block. Now the block just kind of falls off because there wasn't enough momentum to carry it that far. See, the after contact velocity, as we actually calculated before, 2.381. If we go back, the 2.38 was correct. So we're gonna have to change that velocity if we want to get the block to go a little farther. So hit reset. I'm gonna run again. So we have that. What we'll do is we'll make the block lighter instead. So we'll make it 10 grams, and we'll keep the bullet mass the same and the velocity the same, and we'll hit fire and we'll see what that does. Fires off. Now we get a little bit of movement. So that should be 41. So let's go to the calculator to see if that works out fine. All right, and if we plug this into the calculator, we should get 50 mass of a bullet times 50, which is times 50, which is the velocity of the bullet, which is 2,500, divided by mass of the bullet plus, and what did we choose? A 10 gram plus that, 166. That's because we did, I guess I put the bullet mass at 50, that's why. So, I kept it at 50. That's why we got the wrong answer. So let's plug that in again. 50 times 50 equals 2,500 divided by 50 plus 10. Let's see, 2,500 divided by, I need to get my parentheses, 50 plus 10. Giving us 41.6667, which is our correct. Sorry about the calculation error. And I can show you how I wrote that in my code. So here we just have, we had to define the block stand, the gun table, the gun. We had to use vectors to define that. All right here, and then it was filled in right down here. That's how we got the animation. The actual animation where the bullet is flying through the air is right here. Oh, actually right here, sorry about that. That's the block. Right here. We had to use this little algorithm to make the bullet fly across the screen. And my equations: mass of the bullet right here. We had to put it in grams, so I multiplied it by 0.001. Initial velocity, this is entered by the user. And then we have the after contact velocity, which is the momentum equation. So V final, which is mass times initial velocity divided by mass plus mass. And yeah, that is my project. Thank you very much.